Hi, and in this lecture we'll begin the first of the lectures, at least, that are related to the topics coming from Chapter 5. In Chapter 5, it addresses the control of microbial growth. Just a quick glimpse of history here to emphasize a important individual in the development of procedures to control microbial growth, Joseph Lister. Lister was a British physician whose work led to significant reductions in post-operative infection rates. He originally used a chemical called phenol to reduce the microbial populations in surgical wounds and also just general wounds. And due to that, ultimately saw there was a rapid decline in the number of post-operative infections. His work is considered foundational, so to speak, in establishing the protocols necessary to, sanitize surgical instruments today, and also the practices most surgeons use in order to try to control post-operative infections. Due to his work, you can see down at the bottom kind of a fun fact there, so to speak. Listerine, a very commonly used antiseptic mouthwash now, was originally named after him due to the importance of his work early on. This slide is here to try to emphasize the practical aspects to controlling microbial growth on an everyday basis. Basically, when we look at controlling microbial growth, what we're going to do is essentially allow us to limit the spread of disease. Obviously, you think of things such as maybe the influenza virus, even the common cold, for instance. By practicing good control methods, we're able to limit the spread of those diseases. So very important on a practical basis. But even when it comes to situations such as the hospital, where we try to control nosocomial infections, which are hospital acquired infections, we want to control that microbial growth. And even from an industrial standpoint, you see toward the bottom there, when it comes to food production, you want to try and prevent the spoilage of food. So a number of different practical applications when it comes to the control of microbial growth. One of the things I would tell you all to emphasize for this particular chapter are definitions. You're going to see many terms that you probably have commonly used, but maybe have never been given a specific definition for. So with this chapter, you'll definitely need to work on those because it'll be something that you see on your exam. We'll start with the concept of sterilization. When you consider sterilization, as it says here in the slide, it's the removal or destruction of all microorganisms and viruses. There's a key concept to take away with that as well, that being that you're also going to destroy endospores. So you're going to destroy any living microorganisms along with the viruses as well as endospores. However, we don't really consider prions and some of those proteinaceous possible pathogens to be in the category of removal, at least when we consider for sterilization. Next up is disinfection. Disinfection is the elimination of most or all pathogens from a given source. Two chemical categories used to achieve disinfection. You're going to have disinfectants, which are used on inanimate objects, and then antiseptics, which are used on living tissue. So it's again necessary, I'll say it that way actually, that you guys kind of differentiate between disinfectants and antiseptics. Once again, disinfectants being used on inanimate objects, whereas antiseptics used on living tissues. Up underneath the category of disinfectants, you can see what are called germicides. Germicides are chemicals that literally kill microbes. Whenever you see a chemical ending in CIDE, side, or you might see the ending cidal, side or cidal refers to a chemical that kills. So as you can see, three different categories of killing chemicals there: bactericides, fungicides, and also virucides. Each one responsible for killing a particular category of microbe. So bactericides kill bacteria, fungicides kill fungi, virucides kill viruses. So not really much of a stretch to figure out what they kill. Just definitely keep in mind, once again, sides or cidal chemicals kill whatever respective microbe is associated with them. Next up, decontamination. Decontamination reduces the pathogen number to a safe level. Multiple ways to try and achieve decontamination. You can see washing, heat, and chemicals. We'll talk about some of these as we discuss later topics in the chapter. Next up, sanitization. Sanitization relates to decontamination, But as it says there, it's a little bit different because it substantially reduces the microbial population to accepted health standards. And the key there is accepted health standards. In many cases, sanitization doesn't really require a specific level of control. It may mean that you have to perform a sanitization method for a given amount of time or whatever the case may be. And then it would be accepted that, well, your item would be sanitized to acceptable levels. Preservation is delaying the spoilage of perishable products. This in particular applies to food and some other items as well. In a lot of cases, what we see is that microbes are omnipresent in these various items, especially when you consider food. No food is sterile, so to speak. But what we want to do in order to preserve that food is, well, slow down the growth of those organisms that are there. And that's where agents that are what we call static come into play. So whenever you see static, such as what you see here in the slide with bacteriostatic, these chemicals are necessary, or rather used, to slow down the growth of various microbes. So bacteriostatic versus bactericidal. One agent, the bactericidal agent, would kill the bacteria. The other one, the bacteriostatic agent, would slow down the growth and ultimately preserve whatever material it was applied to. Pasteurization, a process evolved, or rather invented by Louis Pasteur, actually involves the brief heating of an item in order to reduce the number of organisms that may cause spoilage. It doesn't really destroy all the pathogens necessarily. It doesn't really interfere with the base characteristics of the product, but it just reduces the number of organisms present. For instance, many of the beverages we consume are pasteurized. That means they're briefly heated to reduce the microbial count, but at the end of the day, there's still microbes there, which is why eventually, if you don't consume it within a given amount of time, it could lead to spoilage. This slide just kind of demonstrates several different approaches to control from a visual perspective, whether we're dealing with the, as you can see up here, the food industry, where you practice proper safety techniques to try to prevent contamination of that food, as well as limit or decrease the rate of spoilage. You've got a water treatment facility here, surgical arenas, as well as a laboratory. So many different practical applications for the approaches to control that we just mentioned there. In our daily life, what's typically sufficient is, and what's the most important approach to control as well, in our daily life is actually going to be hand washing. We use soaps. Soap actually is going to be combined with water, and ultimately that will interfere with the cellular membranes of those particular microbes, and doing so ultimately reduces the microbial count. Eventually, as you can kind of assume here, eventually that allows us to have significant control over the spread of many common disorders due to the cleaning, so to speak, of our hands with soap and water. You can see other control methods are used daily. Heating foods, for instance, is a way to help control the microbial count. We clean surfaces and also refrigeration there. Hospitals, as I mentioned to you before, where we really try to prevent what we call nosocomial or healthcare associated infections. You know, hospitals are like prime breeding grounds for most pathogens, because when you're sick, that's where you go. So the pathogens are there. Combine that with the fact that many individuals are immunocompromised, just to the fact that they may be sick as well, or their bodies may be stressed. So at the end of the day, it's very important to try and control those microbial organisms, at least the growth of them, in a healthcare facility, because, well, you're more likely to become infected in a healthcare setting as opposed to being at home. You can see here, we'll very quickly mention hospitals and other healthcare facilities. We just mentioned the hospital part, but, we could expand that, to include surgical instruments. You have to ultimately sterilize those to avoid introducing infection to some of the tissues. The prions, as we mentioned earlier, these proteinaceous infectious proteins, they're a new concern, relatively speaking, and very difficult to destroy. But, once again, this is just expanding that concept where we have to take these approaches to control in order to help limit some of the spreads of infection there. The laboratory, as I mentioned to you earlier, we routinely work with cultures, so it's important that we try to achieve control not only to ensure the viability of the experiments being conducted, but to also ensure that we don't have contamination of the folks working in the lab and other areas within the lab. So we use something called the aseptic technique. We discuss this in greater detail in the laboratory courses in order to prevent that contamination of the samples you may be working with, the workers, and also in the environment. So it's not necessary that you actually understand the actual steps in the technique, but what I would say is that you definitely want to be aware of what the aseptic technique is utilized in order to prevent contamination of samples, workers, and also the environment. As you can see here, the CDC definitely has guidelines for working with those microbes. All of our labs here at DCC are considered what we call a biosafety level 1, BSL-1 lab. We don't work with any pathogens, essentially. And you can go all the way up to a BSL-4 lab in which you work with lethal pathogens, and those are honestly under lock and key, and those would be CDC regulated labs, essentially. Here we have the necessary information related to control of microbial growth for food and food production facilities. Obviously, this has become more of an important situation, as we've seen here recently in the news with things like E. coli contamination and lettuce and recalls that have recently been done. But nonetheless, important here to try and maintain the growth of microbes on our food. Several different approaches. You can heat the food in order to try and control the microbial growth. There are different chemical additives that can be used. UV radiation also is a very commonly used process to control microbial growth in the food industry as well. Once again, as we mentioned, water treatment facilities, obviously they're necessary in order to try and provide us with clean drinking water. Most traditionally, chlorine is used to try and decontaminate most municipal water supplies. You can see there are some potentially drawbacks with that. They can react with chlorine, that is, can react with naturally occurring chemicals to form what are called disinfection byproducts. And then some of these can be linked to long-term health effects. There are some organisms that become resistant to chlorine. Some actually form protective structures that try and prevent the effects of chlorine gas there. So very important, once again, to kind of summarize here, that we adequately treat water, obviously, that we use for everyday usage as far as drinking and cooking and things of that nature. Ultimately, a lot of times, like I said, chlorine is used to try and ensure that those municipal water supplies are properly protected. Other industries, pharmaceuticals, cosmetics, deodorants, so forth and so on, cannot carry microbial contamination as well for obvious reasons. They're introduced into the body, the surface of the skin, things like that. So you want to limit the microbial growth there. So this is kind of the basic background to this chapter, where we looked at several different definitive definitions, so to speak, of some terms that you probably used before. Took a little bit of a look at some of the various ways and practical applications for control of microbial growth. And then the other lectures to follow, we'll talk about specifically, how we go about evaluating what method of control we choose, as well as some of the specific methods as well.